Okay, so it's 1:02. So that means that we should start with the parallel meetings, the open parallel meetings called hands-on workshop focused on fair research data, fair tools and software. This workshop is kind of like organized within this conference with the aim to help the Educ Alliance, one of the university alliance where Masaryk University is involved, to talk about topics interesting in the field of fair data and EOSC in general. How this is going to be, we are going to have 3 presentations. I will invite my colleagues Michal Růžička, Tomáš Svoboda and Tereza Slanináková, and they are going to tackle different aspects of fair world, fair ecosystem. Yeah, we are going to start with basically the fair data management, then we are going to move to the fair data management in practice on one example, and then an important topic that is rising every day higher and higher in importance is fair research software that is going to be delivered by Tereza. These presentations should be somehow practical, so colleagues are going to try to describe it in a hands-on way, but please definitely use your questions. I will try to moderate it and try to have it as a, I would say, not moderated discussion, but streamlined discussion, something like that. I have one organizational thing. My colleague Olga here is going to send a list that you have to sign yourself again, because it's a co-organized workshop, so please don't hesitate to sign your name again, even if you signed the registration for the whole event. This is the special thing for this workshop. I always welcome online participants. Please, you remember the Slido link. Don't hesitate to ask questions via Slido. We will try to somehow incorporate it as well to the workshop. So now I would like to ask Michal Růžička to come on the stage. He is basically the core data steward at Masaryk University and my dear colleague from the Open Science team. So please, Michal, make your part of the workshop happen. Thank you very much, and please welcome him on the stage.
Thank you. Thank you for your words, and good afternoon. As you have heard, it will be more practical. In fact, I will be still a bit on theory level, but don't worry, we will be more and more practical in the course of the time of this workshop. So I hope we can start now. This workshop is primarily about research data. Does it work? Yeah, perfect. So I will try to make a frame for this. I will begin with some illustration of research data lifecycle in the process. Then we will see what kinds of data we have in the research. And then I will try to start it more practical. I will show you some examples of fair supporting tools that are or will be delivered with NRP project. And then I will pass the word to my colleagues with even more practical examples. So I really like this schema. I'm using it a lot on my presentations as it shows how many things have to happen in the research project with research data, then some kind of classical research output, research publication that's usually produced roughly in this phase of the project is published, and what other things have to happen after the publication of after the publication. Yeah, you have to preserve the data and in current practice also share and reuse it. So That's very important. We are now focusing on the data, but please be aware that everything starts with plan. That's the reason why data management plans are now required, as these are tools that will help you with proper preparation of all the steps that have to happen with the data. In the collection phase, you are now more and more reusing other data, and of course, if you should be able to reuse someone else's data, you need it in a good shape. That you have to be able to find it. You need proper metadata description to know what exactly these data are, if they are useful for you, etc. That will help you with process and analysis. You also have to store it somewhere, and NRP repositories of National Repository Platform can be the place you can store and share the data, and then it will be reusable by others. So, you probably heard research data, maybe managed data, definitely fair data. Some people are scared of open data. So how they organized? If we see all the data, all the zeros and ones in our world as this big circle, then just a subset of them can be called managed. The rest data in this area are in fact more or less unusable for us, as we don't know what the data describe, when were collected, whether we can use it, what's the license, etc. So the absolutely minimum are managed data. You have to be aware who created them, when, how to interpret them. Just the data are completely useless if you don't know what they mean, if you don't know how to get the information from the data. So fair data is another subset that provides some concrete, or at least somehow concrete requirements on the management of the data and the properties they should have. And open data are somewhere between when the specific property of these is its free availability to everyone. One important thing is it's completely okay if data that are fair are not publicly available. It's completely okay, even in the fair description there is a written part of authentication and management of access. So fair data can definitely be some data that are not publicly available, and it's very important. And with EOSC implementation in the Czech Republic, we definitely count on this. So more on data and their properties. In 15 years ago, Sir Tim Berners-Lee published some 5 stars schema of data, and the lowest level is the data is somehow available on the web. That means, for example, PDF with scanned images of the pages. It's definitely better than nothing, but you probably know that that's something you probably are not going to process. It's more or less machine unprocessable. So the level 2 is it's a machine readable format. If it's a Microsoft Excel spreadsheet, it's better than a PDF. But if you are a programmer, you probably know that CSV is definitely better than Excel sheet. So some kind of open, non-proprietary, machine readable format is level 3. and everything more is for better understanding. You definitely should use some kind of persistent identifiers to uniquely and persistently point to the particular data. And if you even link all the data with references, then you have a linked web, and that's what we are going towards. So you probably know that FAIR is an acronym of findable, accessible, interoperable, and reusable. But it's in human language. Findable, make it available on the web. In machine readable format. So Google is able to provide you with results, search results that include these data. And persistent identifiers are important here to distinguish between different versions, etc. Accessibility is in fact about standard technologies and standards when accessing the data. So now it means something like HTTPS or S3 protocol for accessing object storages, etc. What's important? Use some common standard and standard in the field. It can happen that in different fields, different standards for accessing data are needed. For example, in medicine, there is something like PACS protocol used for accessing data from bioimaging. That's kind of standard. That's probably not used in other disciplines, but in medicine it's common. And FAIR principles are completely okay with this, that different fields use different standards. Interoperable, that's more or less the same as accessibility, but not about the access protocols, but about the data and metadata themselves. So use standard field-specific formats of data and metadata. And reuse, it's something that's the goal of all the previews. One important thing is please use clear license declaration. Optimally, it will be some open license like CC BY or CC0, but definitely you have to declare the license. If data or metadata are not licensed, no one will be able to use it. And another important thing, think about provenance metadata. That's something that's not completely common now. There are some standards like W3C Prof standard, but it's very important. Provenance metadata are trying to record all the operations with the data that happened from their initial creation to the current point in time. So it can be metadata of the machine that was used to measure the data set, when, by whom, how calibrated, who converted the raw data from the instrument to some open format, when it was passed to another institution. It's applicable also to physical samples. So in biobanks, it can be used to keep recording of storing or passing the physical samples between institutions, etc. So another important thing in the whole ecosystem, especially if you are trying to keep a record of some research in its complexity. So these are basic FAIR principles. It's really a high-level schema, and in different fields, research groups, projects, we have to somehow apply it in more details. One of the possible solution is FIP profile. FIP means Fair Implementation Profile, and that's more or less some protocol. This is called mini questionnaire. That's a very simple form that's available in this web page, at this web page, and it's more or less a declaration how particular requirements of the fair are fulfilled in this project, research group, research area. So it's trying to provide a particular concrete implementation. For example, if F1 first requirement of findable principle is use of persistent unique identifiers for the metadata records, then the fair enabling resource is a particular type of identifier, and in this it's, for example, DOI, or you can use persistent URL or ARC on something else, but now you are declaring the particular implementation, particular standards you really are using. So that's the theory and high-level overview. Now, as you probably know, here in the Czech Republic, we are implementing, or some projects are running under the umbrella of EOSC CZ implementation. One of them is a National Repository Platform. That's a project that's going to provide ecosystem for building repositories. And one of the important things is we are going to provide a platform that will help you to fulfill FAIR principles. Now you can see a schema of FAIR implementation in NRP. You can see repositories are important thing that are part of NDI. We see the metadata are also important thing, as they are describing data sets that are stored in the repository. You can see there is a note on automation. One of the important properties of this is we are trying to do as much as possible with machine readable standards, APIs that are usable by machines. So we are trying to provide a system that will be able to handle lots of data and process them in an automatic manner. You can see we are also going to use the FIP protocols to declare particular standards for processing, etc. Now, in more practical things, as I said, FAIR data can be non-open, non-freely available. One of the important things we are going to provide with NRP is strong data access control with fine granularity to control access to the data sets. It's going to be connected with a federated authentication system, so you are not going to create yet another user account, but you will use user accounts from your institutions that will in turn help us to keep link to your affiliations and other things. So that's something will be tightly integrated with NRP. Another thing is support for the metadata and automated collection of metadata. I'm sorry for this. It seems the presentation computer does not have proper fonts installed, so sorry for this. We know that a lot of research fields are using some instruments, and one task of NRP is interaction or extraction of metadata from these instruments in automatic manner. So the idea is if you have some instrument, you will be able to directly connect it with NRP platform and get data and metadata to the data storages in this platform to be usable for next analysis and further processing of this. Machine actionability is important, as I told before. We are going to integrate some tools for automation of data management plans preparation. Again, we want to read as much of available data from the infrastructure configuration of the repositories, metadata of the stored data sets, etc. Everything should be available through API. We are also going to support reuse with support for licenses. We are going to prepare a kind of license chooser that will help the researchers to choose the proper license for their data set. On the other hand, the information will be machine readable and so usable for this use of or generational support of data management plans and other things. And very important are metadata. As part of the NRP implementation, tool called Data Spectre is under development, and that's tool that's handling different data standards. You probably heard DCAT or DataSite. You maybe know that there are specific application profiles of these data metadata schema that are even country specific. And this tool is trying to, in automatic formal manner, track different metadata schemas and their linkage and changes, and validate changes if some change is made in one schema to see the propagation of the changes to the child schemas and see if it's still coherent and it still works. And this work will hopefully be used at European level, so some standard help tool that will be used not only here in the Czech Republic, but the EOSC level. So that's something you can get from NRP. That's all from me from the high level overview of this. And if you have any questions, please ask. And I'm going to pass floor to my colleagues with even more practical things and presentations. Thank you.
Okay, thank you, Michal. Questions for Michal? Because doing hands-on workshop with 50 people, it's a little bit difficult, you know. So I would ask you, please, can you raise your hand if there are no new information for you, what Michal just presented? That you know completely everything that was there.
Well.
Okay, so good. Who learned something? Good. So that's
Great.
Nice.
Thanks.
Yeah. Okay, so do we have any question on Slido?
No.
Nothing. Okay, so Michal will be here. Be here during the whole session. So now let's move to Tomáš, right?
Yeah. Yes.
Thank you. And please, if you can put his presentation over there. And yeah, I will give it to him. I wanted to give it to him in the end. So this is going to be really hands-on, you know, like that. Thank you, Michal. Okay, Tom, floor is yours. Thank you.
Thank you, Jirka. Hello, my name is Tomáš Svoboda. I'm from Central European Institute of Technology. located here in Brno at Masaryk University. And I was asked to have a short presentation about how we deal with research data at core facility MAFIR at CETEC to have fair data. So, at first, briefly introduction. CETEC has 12 core facilities which provide their services to research groups. There are facilities like cellular imaging, genomics, or MAFIL. MAFIL, whole name is Multimodal and Functional Imaging Laboratory, provides imaging services to the users in the area of neuroimaging and human brain mapping. There is important word there, human. So it means that we work with personal data. We work with live people. So we have to cope with data in a special manner to be compliant with law. We have equipment like magnetic resonance, EEG, electroencephalograph, and others like pulse detectors, movements detectors, and we can do simultaneous measurements like there are equipment to monitor electric activity in brain during MR measurement. MAFIL is part of Czech bioimaging infrastructure. Professor Kozubek speak about Czech bioimaging yesterday. So we started with a verification process about 5 years ago. I would say it was before start of IOSC initiative, or in Czech Republic maybe. And what was the reason? What was the motivation? We would like to have trustworthy in produced data. There were requirements of grant agencies, especially European, but now there are also requirements at national agencies. Have fair data is required by journals. We should have fair data. We like to store data in infrastructures like national repository platform storages, and we would like to move towards open data. So, what does it mean, fair in MAFIL context? Michal spoke about fair in general way. I try to add some specific notes to this. Data should be findable. For us, it means that every raw data sets or derived data sets are have unique identifier. So we can associate it to one single measurement. We are able to assign a DOI, and we have all data in searchable form in repository. Accessible. As I said, we work with personal details, so we have defined policies concerning accessing the data. So the data are accessible only to the researchers and authorized person. And all metadata remains available also after anonymization. I will speak about anonymization later, except, of course, details which can lead to identification of a single person. Interoperable for us means that we use well-known standard format bits, brain imaging data structure. It's like zip archive, and it defines directory hierarchy and content of specified directories. Like there should be pictures, there should be some JSON with specified metadata. To every neuroscientist understand file in bits formats. And the last, reusable, at the level of data retrieved in Mafil, there are, as I said, more sources, MR, EEG, but we link the data together to have this connection between data from other sources to have possibility to process it together. And also researchers can add some data to our Mafil data because I will speak it about later, and they can do it until anonymizations take place. So before I will speak about data set or data lifecycle in Mafil, I should speak about project lifecycle in Mafil, because if we haven't got a properly defined project, we haven't got fair data sets. So at the beginning, there is a researcher who has an idea, some research idea. She or he can consult it with our Mafil experts. We can mediate he or she with some infrastructure like check bioimaging or Eurobioimaging. And if it continues, there are also some requirements, administrative requirements like fill project details, or it can be, some research can be approval of ethic committee. For example, there were a research when pictures with some violent content was shown to volunteers in magnetic resonance, and researcher observe which it do with their brain, but the researcher should ask to ethic committee if it is okay to show people some inappropriate content, and so on. So after these formalities, there is technical preparation phase, which leads to some measurement protocol which define every step of future measurements. Because to have fair data, to have proper data, all measurements have to be the same, in same environment, in same manner. So at the end of this phase, there is something like a cookbook which describe measurement process. And after it, we can start measuring. We are finding, we find and book volunteers to measurements. We have a list of volunteers, and we can take from the list volunteers we would need. So, for example, some research can work with people above 50, so we can take this from our system. Volunteer is invited to magnetic resonance. Data are acquired, processed, and the data are handed over to the researcher, or we can also do some analysis and also provide analysis to researcher. This is a quick look to project details form in our information system. There are many fields. Maybe there is some progress, something like progress bar. Project is at the beginning potential, after it is in preparation, in measurement, and finally it end in end state. So now about data. I intentionally use word data here, not data set live, because it's quite tricky. What is data set? Is data set a result of measurement of one man, or is data set 10 or 100 measurements but its question, I would answer that every answer is right. It depends of the purpose. So there is a volunteer. At first, he or she fill volunteer questionnaire. There are at first some safety questions, like if he or she has some metal part in their body because it is contraindicatory with measurement at magnetic resonance. And there are also some questions research specific, like do you ever have déjà vu feeling? It was research there, I like it there. After a questionnaire is sent, the system decided if the volunteer can continue to research, and if so, he or she go to the device, he or she is scanned to some special, and the data are stored in some special format in a system called PACS, Picture Archive Communication System. It is system primarily focused on hospitals, to running in hospitals. And it is a purpose we have to enhance the system with our own system, because we need more complex queries and so on in research. So metadata from technical metadata from PACS, like the thickness of images, setting of device, are automatically imported to our database. Also, personal details and answers of volunteers are also imported there. So this is the central point, central information system of our laboratory. I can show you pictures of single subsystems. This is the volunteer questionnaire. There are personal details, and after this, safety forms. After this questionnaire, we can we process the images. We don't want to develop it only for usage at Mafil in SATEC, but we try to develop also some reusable components. For example, this is components which load data from PACS to our systems, and it can be used by everybody. We built a REST API for data stored in PACS because there are not so convenient protocol to communication with PACS, and our connector has some benefits like faster responses, because we use some caching to our database, and we can answer complex queries. In hospitals, our queries ordinary, I need everything what there is from a single patient, but our queries are, we need men between 20 and 30 years old, so on. Okay, so now I am here. Another application, measurements protocols. During every measurements, operators have to take notes about the measurement. For example, the volunteer was afraid, or she or he should go to toilet. So everything is important, and they immediately write notes to information system system to have data in the most right form. And yes, this is the central system for data curation, where at the end operator check if everything is all right, and after, if so, the operator check it with some flag that measurement is over. And our holy grail is that finally we would like to hand over data to users, or maybe we would like to export the data to repositories. And we are working at this phase now. So we are try to implement exports to repository named OpenNeuro. It's a well-known community repository and neuroimaging. But they have quite demanding requirements to data to be accepted to this repository. So we have some work in front of us. And we also, in recent days, implementing anonymization to our system, because we have agreement for volunteers to have their data, to have their personal details to 5 or 10 years, it depends, from the last visit of volunteer. So after this period, personal details of a single volunteer should be removed from our central system or also from other systems. And it can be also quite tricky, because many researchers take notes outside our systems, for example, to Excel, and we try to provide it our system to data, to be the only system where data are, because we have to all personal details under control. And as I said, we now work with export to repositories. There's a question if we should export all to OpenNeuro, or if we should have some own repository or some national repository in Czech Republic. There are discussions nowadays about it. And there are also discussions if we should export to repositories only curated data, processes data, or also raw data. So maybe I would like ask you to answer our question also. So at the end, there are some interesting statistics. We have almost 200 research projects, and we scan almost 9,000 subjects. As you see, we have 33 terabytes of raw data. It isn't so much in the manner of big data, but there is quite many records. So it is all for me. Thank you for your attention.
I got especially interested in 2.6 gigabyte of metadata. That's, in my opinion, quite a lot, no?
Yes, it's quite a lot, but there are also technical metadata, and the device generates many information about, I don't know why, resolution of images and some setting of the device, and setting of the device is stored by every image, and there are thousands of images, thousands of slices in one measurement.
Yeah. It's actually interesting, because there was some discussion in the National Metadata Archive, you know, why we are buying hardware, you know, to store some data in the National Metadata Archive, because it's metadata, you know, but as you can see, only on one laboratory how big the storage can be. Okay, questions? Anyone, anything? Slido? Nothing? Can you put back the questions that you were? No, oh, you can't. So maybe you can ask again the questions. It was raw data or to the open neuro. Actually, what's the technology behind? It's some.
In real, I don't know. I don't know.
Okay.
Yeah, but it's a good question. I should check if it is built upon some well-known repositories, technology like Invenio or something like this.
Because we have Open Neuro, then we had Dataverse yesterday with the Czech Social Data Archive, then we have iVendora that is in the pilot repositories that are now being discussed in the next room, and basically then we have a free systems on the National Repository Platform. So you can see the complexity, how really the system, the national data infrastructure has to be created or being possible to adapt another systems, like systems, not only one repository, but all the systems to share the data across. Zdenka, please, you have a question. Thank you for the question. I know that is
thank you for the presentation.
Afternoon after lunch, but ask. Zdenka, thank you.
Regarding your question about if being in a national repository platform, actually I thought that there is in preparation imaging repository for animal and human brains and other pictures or images, sorry.
Yeah.
So you are not part of this team because it's CETEC, Masaryk University.
We are definitely part of this initiative. I think it is in OS2 project, but as I know, the repository you mentioned is mostly focused to optical images, not to images from magnetic resonance, I think.
So,
what's the difference? Because for me, it's still images of animal or human or this kind of what you have, yeah.
Maybe it's quite similar. Maybe there is slightly different usage. We have many slices which we can visualize to 3D. I don't know if it is same in optical microscopy.
So I would say that basically the question goes like the chemical analytical methods or another imaging methods, you know.
No, my question is that if there is, maybe it should be better named than the repository, because then if I'm having images of kind of big images, I would go to this repository. So maybe this is more general question in the end. When we are building repositories in the platform, how, because there are these communities, maybe, just to explain.
Yeah, definitely.
I think we are speaking about two communities in one repository, but it's called repository. So that I'm just surprised that you are not part of this repository, sorry. But thank you.
Maybe a comment over there?
Hi, maybe I'm a little bit naive, but what I understood is that this national repository is not going to be one repository, but like communication between different repositories, because some labs, they already established their own repositories. They are extending them. And then there's going to be this huge national repository. So as far as I know, they're going to be like interconnected. And this is this findable part that even if it's in CETEC Muni, you can also play with the data even if you're somewhere abroad. The difference between MRI and light microscopy, I'm working with light microscopy, and the data is not big. The only thing is that they are completely different communities. They are working in a different way and measuring different things. But in the end, they are just data and metadata. So,
and I would continue on that. You mentioned Nicola in last comments, like communities. Yeah. That's basically why we have 500 people in the EOS CZ working groups. This is how we have to start working with the infrastructure that we are building. And I would say that this is, even if Tomáš is presenting the same thing, like someone else at the CETEC, they are still thinking in a research mentality, it's different things, and this is definitely a part of our job, I see Kaya here, our colleague from UX, for the EOSC initiative. So definitely the topic for discussion within the infrastructure. Okay, thank you very much. Yes.
Thank you. Thank you, Tomáš, for a very informative presentation. I have a question regarding the life cycle of this data. Maybe I missed, but in one part of your presentation, you mentioned that the data is anonymized after 5 or 10 years, but you also mentioned something about like deleting of the data. So my question is that, is it just gone, or the personal informations are just removed and this data is going to be just staying there as like some sample?
Maybe I said it wrong, but we don't remove data. We only remove personal information from the data. But it can be also tricky, and it is connected with the second question I presented. If we should store also raw data, because raw data are images, and also if we remove some personal details in metadata, this is images that, or it is images of human face or head. So it is possible to reconstruct to 3D head of a person, and after it we can discover owner of the head, or the specific person. So, but there is a solution. We can use some deface algorithm which can remove face, but we play with parameters of defaces algorithms, because if we deface not much, it isn't sufficient, and the person we can recognize the person. But if we set up it in more aggressive way, it destroys the valuable information in images. So we now work with parameters.
So basically, we have a new idea of spin-off for the Muffle laboratory to launch the company for heads. Okay, understand. Any other question? Slido, anything? If not, so let's move to the third presentation, and then we can have a discussion all together. So thank you very much, Tomáš, once again. Thank you.